Okay, so this is the last time I'll say it, but we've been here for 5 minutes. I've just completed a computer science degree, as has my friend Mike here, and Sam, whose idea it was to have this discussion. I have no idea where he is. One of the things that I was discussing with my professor shortly before leaving university was how programming is being taught, if at all, in schools at the moment in the UK. And it seems, from my understanding of it, that there's perhaps not that much of it, and not from an early age. Now, I was quite fortunate in the schools that I went to, in that I actually went to a technology college, a school and technology college, which from quite an early age we were using programs like Logicator to program little pick chips, so robots running around and things like that. And that was what really got me interested and has led to my sort of choice of career. And one thing that one thing that I equate it to is, in school we're taught 2 types of English. We're taught literature, we're taught language. We're not just taught how to use English, we're taught how to write it. In a school it seems that we're taught how to use a computer, but we're not taught how they work or how to develop anything for them. And I think we're missing out on teaching people quite a big part of what a computer can do. I've never been satisfied with somebody putting a computer in front of me or a phone in front of me and saying, okay, that does everything I need. Because I think there's always room for improvement of what's already there, or developing things from the start. And I think that's true in business as well. I think a business where none of the staff are literate in writing computer programs rather than just using them is missing out on quite a lot of opportunity. And you've only got to go into your average office in the UK and you'll see people doing things that, as a more technical person, you look and you think, why are you doing that? You're wasting so much time, you could do this in so much more efficient ways. But because they've not been taught from an early age, from a sort of school, college age even, I believe I'm right in saying ICT is now, I think it's now compulsory in secondary schools, but actual computing isn't. So again, it's the whole argument of sort of whether you're taught to use something or how to use it properly, and how to develop things for it. So I haven't really prepared a massive amount of things to say. I was just hoping to kick off a bit of a discussion really, and ask if any of you have any experiences that you've come across in your lines of work or with hobbies, and ways that we could involve people, or what you think the state of education with computing is at the moment. So,
the first thing I thought of when I saw the title for the discussion, thought about my own background and how I'm doing a job now that I couldn't have conceived of doing. Yeah. Okay. But I think there were things that I was doing that kind of led up to, even though web development wasn't an option. So I think even if it's not taught in school, I think there should be students should be encouraged at any level to learn in their own time. And one could say that they could do that anyway, but some aren't just even the idea. Teachers need to think more about how to feed their students in a way that excites, motivates, and says, this is what we're going to cover in the lesson, but identify skills in people, and even if they're not experts themselves, encourage them to pursue those in their own time. Because even at university level, I did a degree in computing. Did it make me a good programmer? Not directly. It was what I did in my own time as well. So I think that could help in any area. That could be applicable in every area. I do think computing should be on the curriculum at some stage, not compulsory, but I think even then you're limited to what you can cover in the classroom. They need to be dabbling, they need to know what resources are available, and yeah, so it's more about kind of just educating them on what to do best with their own time. Yeah.
So what I've got from what you've just said there is it's kind of inspiring them to go away and do their own thing, right? So showing them the tools that they can use, and then saying, here you go, this is what you've got at your disposal, sort of thing. And I'd agree that that's what got my interest. As I said, I was fortunate. My GCSE and AS level computing teacher he wasn't trained in computer science. That wasn't his degree. I think his degree was in mineral estate management or something like that. But he'd sort of done that. He'd changed career halfway through, and decided this was interesting. But because he had an interest and he was able to motivate a class, we actually ended up developing some, it was Visual Basic drag and drop software, the vast majority of it, but it gave a lot of us an interest in that sort of thing. And I think that for me, that was a massive turning point in my decision to do that. I mean, previously I'd done a couple of really simple web pages in HTML and stuff like that, which I think was part of the ICT course, but not as part of anything more complex than that, really.
Just, sorry, going on from what Adam and Nate's been saying, experience-wise, I suppose, relatively speaking, it's not been that long since I was, secondary school, A-level, university. The learning curve I had at university was so steep because all I did at, to be honest, A-level and GCSE ICT was Microsoft Word, Microsoft Excel, Microsoft Access and PowerPoint, and that was it. And then you get thrown in at the deep end for programming, which I'd not done any of.
I appreciate that, because when I started, I took all the increments in the terms I was doing much better.
And then 4 years from now, I'm a technical consultant, and the learning curve was unbelievable, just starting from absolutely nothing, hello world in Java.
I can give you an insight from longer ago. I did computer science at university, but for a long time I was planning to do chemical engineering at university, because I didn't know you could even study computers. So I was in my secondary school, and we were getting ready to choose, do the UCAS, and I don't know if it's still the same now, but choose your university, choose your courses, and look at what grades you need to get. And I was doing maths, physics and chemistry, more out of the fact that I was pretty good at physics and maths. And chemistry was not biology, so I made it a lot easier to choose out of the science faculty, because it couldn't be the other one. And it wasn't until we were kind of choosing, and one of my friends said, "Oh, well, listen, you spend all of your time on computers, why don't you study them?" And I was like, "Oh, you can study them at university?" And they were like, "Yeah." I was like, "Brilliant." So I ended up doing computer science at university, but it just seems, my school encouraged me to use computers all the time, but no one ever told me I could study them until someone just said, "Well, you can." It was my own personal time that led to my interest in it, taking things to bits and that. But it kind of seems that even then we had a problem. Kind of now it's just becoming more and more visible to us that we're not inspiring people to take things to bits, and maybe that's because the teachers or the information that they have isn't good enough to help them help you.
I think it is that inspiration and motivation, though, because from my experience of actually recruiting people in a management position, recruiting ICP, I told this to my boss once and he laughed at me. He said, "John, what are you looking for?" I said, "I'm looking for someone who's nosy." And he laughed at me, and I told him why. I said, "You can fire all the degrees and masters and PhDs if you want and things like that, but the more higher up you go in education, the more specialists you can get." I said, "I'm not looking for that. I'm looking for like a good ground base." And when they come into me, we then teach them the way they're going to do it in real life and real industry. If they've got that interest, if they've got that to be nosy, to look behind the scenes, simple start at the beginning with web development, how's a web page made up of, and then get further and further into server scripts and how servers work and all the rest of it, etc., etc. You go deeper in, learn all that. If they've got that passion to start off with, they will learn that, and they will go and learn that. Someone wants to do it, will do it, and they'll get the real life experiences that they need. And as soon as they get that, then they can develop on that.
One thing I was thinking about when me and Adam wrote this session was that I was really interested. It's really easy to say, yeah, we should do it. But I was wondering, is there a reason why we don't do it earlier yet? Is it because at that age, I think there's a sort of stigma attached to being a geek, and you might be... Well, no, I think...
There's also a massive problem with getting things into the curriculum.
Yeah.
It's really easy to say, we should be teaching our kids this, but there's a huge long process that you have to go through to get from we want the kids to learn this. And it could be like 4 or 5 years later that that's got through all of the approval process, the planning, the lesson schemas, the feeding that information out to the nationwide curriculum for the teacher to actually then say, okay, this is what we're going to learn now, and you all know that 5 years, that's not going to be relevant by the time it reaches where you want it to be. That's a massive hurdle.
So you're saying it sort of moves too fast to write a decent...
Well, accrediting people, and so now, 5 years after they wanted the concept of that course, we're finally getting it at our university. But 5 years, if they'd been able to roll that out 5 years ago, we now have developers coming out of my uni, designers coming out of my uni that have a qualification that would be relevant to this growing industry.
I think one way to like try and get about it is that, like you said, that it takes forever to get something in place. But I think it was Mike who said that he had never done programming and stuff like that. And I never knew what sort of jobs were out there either in IT. And so I went to uni, did my degree in IT, and then I was like, well, what do I do now? I don't want to be a developer. And sorry, offended the whole room there. And so I didn't realise you could do like project management, BA, that sort of stuff. So I think maybe instead of actually teaching the kids to learn how to program or web development, let them know that you could be a web development if you did this, this and this. And maybe attack it from that angle.
Okay, so Michael's trying to make a point here.
Yeah,
so.
people have hinted at it before. It's actually quite a boring subject, computers in schools. And it is. I've taught it on supply. It kind of asks questions like, what does the CPU stand for?
Yeah.
Is this, labelled the mouse? It's basically seems to be a monopoly of Microsoft products. They sell these products into the schools, and then the schools budgeted all this money to have these Microsoft products. Then they have to justify it, and so the whole curriculum is dominated by using spreadsheets, using Microsoft Word, and basically it's a real turn-off. It's almost like typing though. It's not. It's not like using computers to do something clever, to actually, design a program. It's just, like I say, it's almost secretarial work, the teaching in the computer field.
Yeah. Putting sort of computer programming onto the curriculum is really important to move for the computer science.
So it's not just us. It happens in other countries. It happens in Poland.
We're one of the few in Europe.
I think your approach makes sense, that it's available if you have an interest. It's something that's quite interesting. You can play robots, you can do those things, and you have a sort of extracurricular class.
We've just said over here that there's this 5-year possible lag between putting something onto the curriculum and it becoming active on a course. Now, in my view, in the last you look at the last 5, 10, 15 years in that sort of increment, and the requirement for this sort of knowledge, is being able to use a computer, to be able to program a computer, has increased exponentially. And in my view, in the next 5 years, it's going to become as important to business and industry in the UK as subjects such as maths and science. And I think that if you don't act now, if you wait 5 years, then you've got to wait 5 years again when this whole process goes through, and you've got other countries like Germany investing heavily, well, investing is the wrong word, but investing heavily into open source software and getting people using that at an early age. You've got a lot of other EU countries that have some element of teaching programming on a course. Even if it's, my first example was some ridiculous program where I made a turtle move around a screen. Now that's something that's been on the course for a long, long time, and it's really simple algorithms. But having that knowledge is, in my view, essential. And there's probably a higher percentage of computer scientists in here than there would be in a normal group of people. But I think when you look at the balance of industry in the UK at the moment, it's becoming more and more important to have these skills, not necessarily just in a programming job.
I'm a non-tech person. I'm horrified by my own inability with this sort of thing. I wish I was able to use computers. But I think when you're talking about a curriculum, there are multiple purposes for a curriculum. And what you're talking here about sometimes like career education, you're talking about interests and skills. It seems like there are different ways that you could attack this problem. With the 5-year gap, there's Mad Labs Omniversity. You can have like a youth version. In terms of,
there are already plenty of groups out there. There's Young Rewired Stay run by Emma Mulqueeny, who she's just put an e-petition together saying that Year 8 students, where they bring in some kind of programming into the ICT curriculum, is too late, and that it should be brought in much earlier. Aiming for Year 5, and that's what she's looking to try and get discussed in Parliament. So everybody wants to look for that.
Sure.
I'd say we're about halfway through the talk, and we've spent half the time talking about what's wrong, but there's a huge amount of scope for opportunity. There's only one barrier that's stopping computing taking place in school, and that's the teacher, because there's a huge amount of initiatives, as you mentioned, groups. You can't save money because there's a fantastic range of free resources that are out there. There's books, videos, all free, available online. A sad fact is that some of the most successful developers have got to where they are in spite of their education, not because of it. But we still need to be given opportunities for children to experience that. There's a huge... I could reel off like 10, 20 different things at the moment that will help change it, but it's not happening overnight. The curriculum isn't a barrier because the national curriculum will actually allow teachers to teach computing if that's what they want. But the big issue is the teachers' fear. There's a large number of teachers teaching ICT that have come in from a business studies background or something like that, because 10 years ago, people were saying, children don't know how to write a letter, they can't do a spreadsheet. So there was a huge initiative about 10 years ago, put PCs in school, Microsoft Office, that's the way to do it. Now, children are learning it from 5 years old, they can use PowerPoint. So now we need to be moving on to the next step. If you come to, there's a session running in the Doctor Who bit after this, which is about Code Lab, which you may have heard about. It's a project supplying every child in the UK with a computer and the knowledge to program. So when they come out of school at 16, they can create apps on their own.
Can I follow up from that?
Yeah.
Can I follow up from
Yeah.
that? What we do is we go into schools and we teach teachers, we teach kids, we teach gifted and talented groups as well. And I find that one of the big problems is the teachers just don't have much of a clue about computers, IT, programming, any of this. So what they do, they bring us in and we teach the kids. It could be after school classes, it could be during school classes, or we could be just teaching groups of teachers or mixed teachers and kids. And it's a wide variety of subjects, but none of the teachers seem to have the skills, even on basic things like Photoshop. We do other things like Flash, Visual Basic, Dreamweaver, all that kind of stuff. But we're getting constant work to be brought in, either within school time or just after. And the teachers generally are very low quality in the skills. And often the kids are better, but not much. And the skills are greatly lacking in most teachers.
So, sorry, I can't make out your name, but the gentleman in the corner is trying.
Well, I was going to say, one, because my daughter went to second school, parents asked the question, what sort of technical standards do you want? And they said, oh, what's Word, PowerPoint, and so forth, and so on. So at 11 years of age, they expect them to do that. In the work environment, we have people that work for us that don't have those skills. So I think things have moved on, maybe not to something they want to be, but I think we are moving on quite rapidly, things do change over there. So don't just focus on that. It's quite a specialist area programming and so forth, but we are catching up with it. They're far ahead than we were a few years ago.
Can I just say, schools are motivated by results. So if there's a choice between doing a hard GCSE, which contains lots of programming, or doing an easy GCSE, which is labelled the mouse, labelled the keyboard, fill in a spreadsheet for coursework, which the teacher possibly helps you to do, or your relatives help you to do, the school's going to choose the easy option because they want to see there's so many grades, 5 A to C's. They're not going to pick the harder option unless it's actually put there. You know, we want kids who are doing this harder subject of GCSE in programming, but it actually gets the recognition it deserves.
And I think that can apply to a lot of subjects. I think.
Yeah, absolutely.
Yeah. It's true that schools have used some qualifications to play the league tables, but there's a few moves now by the government which will mean that practice will come to an end soon. But one of the other things that's not helping is the fact that in January this year, Michael Gove, the Education Secretary, imposed this EBAC, which isn't actually a qualification. It's a means by where schools can compare each other's results. And if schools want to be perceived as being academic institutions, they can say, well, we've got 80% of our children get the EBAC. And the EBAC, to qualify for it, you have to have a certain number of subjects. It doesn't include computing, but ancient Latin, biblical Hebrew, these sorts of subjects, you do really well. And it's, in effect, the government is saying that ancient Latin, biblical Hebrew, history, all these sorts of things are more important than computing.
Okay, did you want to?
I
Yeah.
also think that it's important to focus on what we're trying to teach them, because only talking about teaching them how to program isn't the right thing, because in a few years' time we'll just have an abundance of programmers. I think what's important in IT is to teach children the concepts of like logical how computers work, I don't think people in schools recognise the correlation between more basic subjects that the children are already doing and or programming or design, whatever.
Okay.
But there's a bigger problem, I think, which isn't just about how to get computing on the course or on the curriculum in school, and it's the fact that you can't anticipate anymore the jobs that people are going to be doing when they leave college, because you're preparing kids for jobs and careers that haven't even been invented yet or haven't even started to happen. So actually, the whole concept of subjects and the curriculum just doesn't work for kids anymore. And actually what you probably need to do is radicalise the whole approach. Start teaching very core, make sure that they have those basic STEM subjects like English, maths, a few basic subjects which are about understanding the world. Develop core skills like thinking skills, problem solving skills, logic, creative thinking, working in teams, all those kind of skills, and then identify what kids are really interested in and what really inspires them, and then start developing a model of learning and education that is more project focused rather than subject focused, that is more interdisciplinary, and where people are really learning what working in the real world is like, rather than in the artificial environment of the school, which isn't working educationally for kids anymore. Kids can't even learn how to read and write in a lot of schools nowadays, let alone do computer programming.
Right, I'm conscious we're running low on time, so if we just have the last couple of points.
I was going to say, probably a lot of children nowadays think of computers as a commodity. Like, it's a generation thing. Years ago, like, when I spoke to my dad, and my dad would like, be really interested about, say, lawnmowers or fridges, how they work, and I won't be interested. I would be interested in computers, and children nowadays have always had computers. So if you're talking to them, they're probably thinking it's just like a lawnmower or a fridge, that type of thing. So you just look at it, and, you think it should work.
Nathan?
I agree that we should be teaching concepts completely, and it's essential that we inspire kids, and they'll be doing, if they're excited about something, they'll do it in their own time. But I can imagine, like, a couple of things. The gentleman over there said how, like, spreadsheets are boring. They are generally boring. But if you're teaching it in a class and you're going along the curriculum, and give the kids an exercise to do with a spreadsheet, and then if they react well to this task and if they're excited about it, pay attention and refer them on to give them something to do in their own time, not homework, but just supplement to just steer them.
There's no reason to want to learn about spreadsheets, because that's half the problem is kids are learning about things and have no idea why they're learning about it.
I think you've just raised an important point there about the sort of picking of people, seeing the signs in people that. Because I did GCSEs in computing, really enjoyed it. ICT, couldn't stand it. It was things like you mentioned. It was copying this text and typing it into Word and printing it off. And realistically, one or two of us did it and printed 10 copies off and handed it around the class. And the problem there was there were a lot of people who'd taken that GCSE. For a start, it was a double GCSE. So as you're saying, league tables, fantastic. Double GCSE, it's quite easy. You're in a suite of computers with one teacher. She can't see any of the screens in my example. We were just playing games. Well, Facebook wasn't invented at the time, but MySpace it was. But things like that, and I think that's quite a key thing, because there were some of us in that class that were interested, and it was maybe 5 out of the 30. But I think a lot of us got off put by the fact that I understand it's a fact of teaching large classes that you have to keep everyone at roughly the same area, but I found for me that it was just everyone was being held back by the fact that the vast majority had picked it because it was an easy option.
There's a distinction as well that ICT in schools, you're training children how to use particular aspects of software, whereas computing is a discipline and it requires a totally different mindset to thinking skills.
Well, my background is in maths outreach. I just promote maths generally, and I often find myself having to defend. People say, why do we need to learn about stuff like quadratic equations and fractions? And I think it's exactly the same idea, because as well as being a really important thing to get kids able to deal with computers and to program computers and to sort of be comfortable around it, because we're going to need a lot more IT people as computers take over and become more important. I also think that the actual skills of being able to work out what steps you need a program to do, and the kind of very basic, even if you're just writing a toy program that's controlling something really simple, that in itself exercises your brain and gives you logic skills and thinking skills. And there's like a functional skills GCSE now that's kind of this kind of idea, and I think computer programming would be a really nice way to get kind of that kind of brain activity from kids, because it equips you for other things.
Okay, Jack.
Yeah, I'm still at sixth form. I'm in my last year now in year 13, and since I started there 6 years ago, I've been programming. Programming was on the curriculum in my school, which is Altrincham Grammar, and I've learned then through games, as it was. We started off making a simple chase game where you've just got to move your character around the screen and hit the other one, and then pretty much immediately we went on to the more advanced Space Invaders, and then within probably 6 months we'd learn how to make programs which use really complicated ideas, but as a child you're not going to want to know how to program numbers and stuff, so you've got to make it accessible for them as much as you are giving it to them, because nobody's going to want to sit there and make a program that just adds up numbers or doubles numbers or whatever. You need to make it something that you're going to want to do.
Unfortunately, some of those things you do have to know how to do before you can move on and do the interesting things, but I'll put a plug in for some software now that I have nothing to do with the making of. I have no financial interest in whatsoever or anything like that. So my disclaimer's out the way. It's called Alice, and it's part of an animation competition that goes out every year, organised by the University of Manchester and various other universities. And it's a really simple animation package, and it's designed to be used by the higher end of primary school and lower end of secondary school. And it's designed as an introduction to some of the concepts of technically object-oriented programming. I guess you've got rabbit, rabbit.run, things like that, and make a rabbit run across the screen. And little things like that, whilst trivial to probably a lot of us in this room, are more interesting because to someone of that age, they're physically changing what the computer's doing rather than just clicking a button or something like that.